Now we're going to be talking about colligative properties. So a colligative property is based on the number of particles of solute versus the particles of solvent in a solution. Remember that a solution is made up of solute and solvent, where the solute is dissolved in the solvent. And so these properties can be freezing point depression, boiling point elevation, vapor pressure, alterations, and osmotic pressure. Let's walk through a problem together. So in this example, we are told that we have 2 grams of some unknown compound reduces the freezing point of 75 grams of benzene from 5.53 to 4.9. What is the molar mass of the compound? So in this case, you would be given an equation, which is the freezing point depression equation, which takes the form of delta T is equal to Kf times M, where M is molality. And if you remember from a few sections ago, that means mole of solute divided by kilogram of solvent. So once again, what we're given is the mass of the unknown, which is 2 grams. And we're told the mass of the solvent, which is benzene, as the unknown is dissolved in benzene, which is 75 grams. And we're given a delta T, or a change in temperature, which is T final minus T initial. And we know T final and T initial. It goes from 5.53 to 4.9, decreasing. So it goes 4.9 is where we end up. So that's our final minus our initial, which is 5.53, all in degrees Celsius. And so carrying that out, we get there's a change of 0.63 degrees Celsius. And then it asks us, what is the molar mass of the compound? So our goal in this case is molar mass of our unknown. And remember that molar mass is molecular weight. It's the number we find in the periodic table. So it's some amount of grams per mole of our solute. So to start off, we have our equation delta T is equal to KFM. We have our delta T, which is 0.63 degrees Celsius. And KF is a freezing point constant. And so in this case, it wasn't given to the question, but this is a constant for anything that's benzene. So you can just Google it if this is homework. If it's an exam, it'll be given to you. And so I keep putting the F. So we know that for benzene, the KF is 5.1.12 degrees Celsius per molality is equal to KF. And so the only thing that we're missing here is our little m, which again is moles of solute, which we don't know what it is, per kilogram of benzene, which is our solvent. We don't know how many kilograms we have, but we do know how many grams of benzene we have. And so we can go from grams to kilograms, which is just a 1 to 1,000 ratio. So for 75 grams, there are 1,000 grams in a single kilogram. So 1,000 grams per 1 kilogram. Our grams cancel and we end up with 0.075 kg. So now we have an X number of moles of solute divided by 0.075 kilograms. So now the only thing that we're left to find is moles of solute, which is exactly the variable we want to define, because we need our goal for molar mass or molecular weight is grams per mole. And so once we know the number of moles that make up these 2 grams, because we know that the unknown has 2 grams, so we're going to put 2 grams divided by 2 grams means we have how many moles? Because once we divide, we're going to end up with a fraction with a 1 on the bottom, and that means that we can find the molecular weight. So this X number of moles is the same number as X number of moles up here. So carrying out this calculation and plugging everything in, again, delta T is equal to KF times M. And we know delta T is 0.63 degrees Celsius equals KF, which is 5.12 degrees Celsius per molality, times that M we replace with X number of moles of unknown per 0.075 kilograms of benzene. Now to isolate this X, we're going to divide 5.12 to the other side and multiply 0.075 kilograms to the other side as well. So we end up with 0.63 degrees Celsius divided by 5.12 degrees Celsius over molality. And these degrees Celsius cancel. And so 0.63 divided by 5.12 is going to be 0.123. And since those degrees Celsius canceled and we have molality as a unit of the denominator, we inverse that when we put it on top, and that M comes to the top and is a unit in the numerator. And this M, once again, means 0.123 moles unknown divided by kilogram of solvent. So now we have 0.123 mole unknown divided by a kilogram of solvent is equal to X moles over 0.075 kilogram of solvent. Now we can multiply this 0.075 kilograms to both sides. Kilogram units cancel. And on the right, the numbers cancel to isolate X. And we end up with 0.00922, well, 923 moles of unknown is equal to X moles. So we solve for X and it's in the right units. But we don't want moles, we want molar mass of the unknown. So we take now this new value we just calculated. Now that we calculated that 0.00923 moles of unknown, we know that these 0.00923 moles came from the 2 grams. So it's essentially saying the same thing. So now we can say, we know that our goal is molecular weight, which is grams per mole. So we can say for 2 grams, I created 0.00923 moles. And if I carry out this calculation, I get 2 divided by 0.00923. And I end up with 216.68 grams per mole. And that's units of molecular weight. So this would be our answer. Here is another example that you can try on your own. And the colligative property equations are here on the right for your disposal. So we used equation number 2 in that last slide, delta TF equals negative KF big M.